Next, the third type of classification is based on the design and constructional features. Here you have 4 types, and let me explain you one by one. இதுல 4 type இருக்கு, நம்ம ஒவ்வொன்றா பார்ப்போம். So இதுக்கு we have to draw a diagram. The first one is concentric tubes. You know that concentric circles. ஒரு circle இருக்கு, you have a circle with a center. You have another circle, the same center circumscribing the circle. அதாவது ஒரு சர்க்கிள் இருக்கு ஒரு சென்டரோட, இதுக்கு வெளியில இன்னொரு சர்க்கிள் இருக்கு, ரெண்டுக்கும் சேம் சென்டர் இருந்ததுன்னா இது கான்சென்ட்ரிக் சர்க்கிள் சொல்லுவாங்க. அப்ப கான்சென்ட்ரிக் டியூப்னா என்ன? உள்ள ஒரு டியூப் இருக்கும், வெளியில ஒரு டியூப் இருக்கும். சரிங்களா? அப்போ உள்ள ஒரு டியூப் வெளியில ஒரு டியூப் இருந்ததுன்னா யூ ஹேவ் திஸ் அரேஞ்ச்மெண்ட். என்னன்னு சொல்லலாம்? அந்த அரேஞ்ச்மெண்ட் வந்து யூ கேன் சே இட் அஸ் கான்சென்ட்ரிக் டியூப்ஸ். ஸோ இந்த மாதிரி ஒரு ஹீட் எக்ஸ்சேஞ்சர் இப்போ அதை நம்ம எப்படி இருக்கும்னு டிரா பண்ண போறோம். ஸோ the outermost body இது வந்து ஷெல்லுன்னு சொல்லலாம். You can see that now what I'm going to draw now here. இதுதான் outermost body, it is called a shell. இது வந்து அவுட்லெட், a hot fluid ஓட அவுட்லெட், and இது வந்து hot fluid ஓட, again I'm going to draw that inlet. இது வந்து hot fluid ஓட inlet. Okay, this is hot fluid outlet and this is hot fluid inlet. Okay, fine. அதுக்கப்புறம் then when you draw here, இங்க நம்ம வந்து we can bring this here and draw the cold fluid outlet. This is the cold fluid outlet, and you draw here the cold fluid inlet. That's the cold fluid inlet. This is the cold fluid inlet. இதுக்கப்புறம் நீங்க you have to join this line here. Okay, fine. So let me mark it out. This is the cold fluid in, cold fluid in, okay, and this is the cold fluid out. So when I say it is cold fluid, it means after exchange of heat this will become hot. This will become hot. It does not mean that it enters as a cold fluid and exits as a cold fluid. So in order to represent it, we are writing as cold fluid in and cold fluid out. Actually, the cold fluid enter into the heat exchanger, exchange the energy with the hot fluid, come out as hot fluid. And simultaneously, the cold fluid will enter into the heat exchanger, and then the cold fluid will, the hot fluid will enter into the heat exchanger, and it will exchange heat with the cold fluid, and it will come out as cold fluid. So hot fluid in, and here you have the hot fluid out, hot fluid out, hot fluid out here. Now, how does the hot fluid go? The hot fluid flows through pipes. Let me draw those pipes here. The hot fluid flows through pipes. So let me draw the pipes here. So this is an arrangement what you have here. These are some arrangements what you have in heat exchanger. I'm trying to give you different colors so that you can understand it. And here I have a tube here. I have a partition here. I have 2 tubes here. This is one tube here. I have one tube through which the hot fluid is flowing, and I have another tube here through which the hot fluid flows, and so simultaneously consequently you have the third tube here and the fourth one here. So it is not necessary that you have 4 tubes, you have n number of tubes, a bundle of tubes. So we are representing it by 4 tubes here through which the hot fluid is going to flow. So this is the fluid flow, hot fluid that flows through the tubes here, and you can see here. it flows here, it comes out here, and then, okay, it comes out here. Similarly, the hot fluid enters here, see, it enters here, okay, fine, and comes out here. Both accumulate and flow through this tube again. So here, every time the fluid flows through the tubes, it exchanges heat with the energy with the cold fluid. And see, you can see this outlet. Fine. So how do you separate the hot and cold fluid here? It is separated by baffles or a partition here, and here you have a partition, so that the hot fluid which is entering here, uh, it cannot move to the upper portion here. So the hot fluid is separated by a partition here, and now the cold fluid which enters here, how does it pass through all the tubes? எப்படி எல்லா டியூப் வழியாவே பாஸ் ஆகும், எப்படி போகும் அப்படின்றதுக்காக we are keeping some plates which is called as baffles. So என்ன பண்றோம்னா இந்த மாதிரி தடுத்துறோம் நம்ம fluid. See, இந்த மாதிரி கிராஸா இந்த மாதிரி பிளேட் வச்சிடறோம். You weld some plates so that அதே மாதிரி இந்த இடத்துல you place some plates here. You have some plates here. Okay, fine. And here also you can have some plates here. Okay, you can have some plates here. Say now what will happen? Now you can see. Now I'll mark this cold fluid in a brown color or another color, for example. Let me mark it in blue color. In the cold fluid, you can see the cold fluid which enters here. It passes through here, and from here it passes here. Okay, and then from here it passes here. You can see the direction. So these plates are the baffle plates. These plates are the baffle plates. It changes the direction of the fluid so that it comes in contact with the surface of the hot fluid, so that maximum heat exchange can take place. So this is a type of heat exchanger, and this is the outermost body is called as the shell, and the innermost are called as tube. So this is concentric tube heat exchanger. So the outermost is one tube, the inner is a bundle of tubes here. So this can further be written as one shell. This is further be written as one shell. You have only one shell here, one outermost body, okay, and one shell pass. You can call it as one shell pass, and see, you can, how many tubes are there? You can see here hot fluid enters through these tubes. So how many tubes? It enters through 2 tubes. Am I right? The entry is through 2 tubes. 2 tube வழியா தான் enter ஆகுது. இங்க 4 டியூப் இருக்கு, 1 2 3 4, but enters through only 2 tubes. ஒரு டியூப்ல என்டர் ஆகி திருப்பி இன்னொரு டியூப் வழியா போகுது. அப்ப என்னது, எத்தனை பாஸ்? So it is having 2 tube pass heat exchanger. புரியுதுங்களா? I hope you understand what I'm saying here. So what happens? It comes into the cold fluid twice. இங்க பாருங்க, இப்படி போகும்போது இப்படி போகுதுங்களா, இங்க கோல்டு ஃப்ளூயிடோட கான்டாக்ட் இருக்குங்களா, திருப்பியும் இங்க போய் இங்க என்டர் ஆகும் போதும் you can see the cold fluid. So ரெண்டு டைம் cold fluidோட இன்டைரக்டா கான்டாக்ட்ல இருக்கு, not in direct contact, this is indirect contact. So it is called as one shell. The outermost தான் வந்து shell. You have one shell pass. One shell pass ஏன் சொல்றோம் அப்படின்னா, ஒரு டைம் தான் ஷெல்ல போகுது. இங்க என்டர் ஆச்சு அப்படின்னா ஒரே டைம் ஷெல்ல போகுது. 2 tube pass. It passes through 2 tubes. Got it? So cold fluid பாருங்க, ஒரு ஷெல், and hot fluid 2 tube passes. So let me draw 2 shell. The 2 shell and 4 pass. How can you have? So you have heat exchanges of that kind also. So here I'm going to draw the B category 2 shell. I'm going to draw 2 shells, so you'll understand when we draw 2 shell and 4 pass. 2 shell and 4 pass heat exchanger. 2 shell and 4 pass heat exchanger. So let me first draw the 2 shells, and you'll understand the diagram once I draw it. So this is the shell what I'm going to draw. Okay, I have divided this. This is going to be the shell here. Okay, so right, consider and okay, fine. So this is going to be the shell. This is going to be the shell. Okay, fine. Maybe this line is not parallel here, but this is the shell, and I'll draw the tube so that you can understand the tubes here. So this is the tube that is. So these are the two shells, and this is the tube which is entering here. You can see this is the tube which goes here, and again you take back the tube here. You take back the tube here. See. Okay, fine. And then the tube enters to the second shell. This is the first shell. This is the first shell, and now it enters to the tube enters to the second shell. Okay, it enters to the second shell, and now it again returns and exits here. So the blue color what we have drawn here is nothing. The black color what we have drawn is this is nothing but the shell. This is nothing but the shell. So I have shell number, say for example 1, and I have shell number here 2. There are 2 shells, and the blue lines are the pipe which represents the pipe. There are tubes, and you have 2 here, 1 and 2, and 3 and 4. So 4 you have. So 4 times you have 4 passes. 4 pass. Okay, because you can see what do you mean by 4 pass? So when I pass the fluid through the tube, it comes in contact with the other fluid 4 times. So you have 4 pass. So which is the shell fluid? Let us see the shell fluid. We'll draw the shell fluid so we will understand. So I'll give the shell fluid here. This is the shell fluid. The fluid passes here, and you need again baffles here. You need the baffles to change the direction of the fluid so that it comes in contact with the all the tubes, and so yeah, we'll draw the baffles here. Okay, fine. And you have here similarly you have the baffles here. 1, you have 2, and you have 3 baffles. Here you have few baffles, 1, 2, and etc. So now you see here. Now what happens? The fluid, the shell fluid. This is called as the shell fluid. The shell fluid. What happens? It enters here. Okay. Fine. It enters here, flows here, flows here, flows here, goes here, goes here. See, it comes in contact with the pipe. It comes in contact with the pipe. You can see here. It goes here, comes in contact with both the tubes here. So both the tubes, you can see, and then finally it exits. So during the travel, it comes in contact with them all the tubes. You can see here. So this is what now we can draw this. You can see the dotted lines what I've shown you here. It is all. Let me draw it in a solid line. Okay, so that you still have a clear view of this one instead of dotted lines. Okay. Okay, fine. So this is 4 pass, 4 pass, 4 tube pass. So you can represent 4 pass, which is only 4 tube pass. Okay, 4 tube pass, and shell pass is 2 shell pass. So how many shells are there? 1, 2. How many tubes are there? 1, 2, 3, 4. So how much is it? 2 shell pass, 4 tube pass. The previous one was 1 shell pass and 2 tube pass. Okay. I hope now you understand concentric tubes. Similarly, you have bundle. So you have a few bundle of tubes inside the shell, and that you can call it as this shell and tube heat exchanger. The second category, shell and tube heat exchanger, where you have a bundle of tubes, and the third category you can write it as multiple shell and the tube passes, multiple shell I hope you will understand now. Multiple shed and a tube passes, and the last category of this one is the compact heat exchangers. Compact heat exchangers. Heat exchangers. Compact heat exchangers, and this is very, very, very important as far as compact heat exchange is concerned. So this is very, very important. Compact heat exchangers. So compact is for a given heat transfer rate of heat transfer, the area should be minimum. The area of the heat exchanger should be minimum, or the space occupied by the heat exchanger should be minimum. In industries, the space is a constraint. So you have to design a heat exchanger which will occupy a minimum space and transfer a maximum heat transfer. Will give a maximum heat transfer. So that is called compact heat exchangers. So the purpose and the aim to design compact heat exchangers to reduce the space. So space is a constraint in industries. You cannot occupy huge spaces. It's going to cost you. So you have to see that you design a heat exchanger which will occupy minimum space. That is, it will have a minimum area and it can exchange maximum heat transfer. When I say area, it is not the area of the heat exchanger where it occupies. It is the area, it's not only the area of the heat exchanger that it occupies the space, it is the area of the tubes also, the area of the tubes, because the heat exchange takes place from one tube to another tube. So if I draw it here, for example, this is the outer tube here, and here you have one more fluid that passes through the inner tube. So inner tube. Now you can see here when I say the outermost a hot fluid is flowing. For example, in the outer tube, a hot fluid is flowing here. Okay, this is hot fluid is flowing, and then inner tube, a cold fluid is flowing, and now a cold fluid is flowing. So when we talk about the area here, so this is the area. So this area, which area? This is the area where the heat exchange takes place here. So when you draw this area, so I can draw this area here. This is the area. So this is pi d. This is pi into d. So you have a circle. The circle circumference of circle is pi d multiplied by, this is the length L into L. Pi d into the length. It gives the surface area. Surface area. Surface area. So this is, so try to keep as short length as possible of tubes and try to exchange the maximum heat so that your material cost will reduce. The heat exchanger effectiveness will be great. The space of it will be less. So that's very, 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 very important. So as far as examination point of view, compact exchangers definition and the need of compact exchangers, heat exchangers is very important. And now the last category of the classification is nothing but based on the physical state, based on the physical state of fluids, based on the physical state of fluids. Okay, you can based on the physical states of fluids, you can classify the heat exchanger into condensers and evaporators. So one is condenser, what you use in power plant, and another one is condensers, and another thing is you have evaporators. So you have in condensers, you have in the power plant, you have condensers again in your refrigeration units, and you have in air conditioning and refrigeration units, you have in air conditioning units, air conditioning units, air conditioning units, in milk chillers, etc. So a lot of examples are the milk chillers. So you have condensers and evaporators both in all these plants. Power plant you have in a refrigeration unit, you have in an air conditioning unit, you have milk chillers, etc. So here condensers and evaporators, as we have seen already, that is the condenser and evaporator, you have phase change that takes place. phase change takes place. Phase change takes place. Okay. In a condenser, what happens is that in a condenser, you have a gaseous fluid that is converted into a liquid fluid in a condenser. And in an evaporator, you have a liquid fluid that is converted into a gaseous fluid. So this is the difference. So in a condenser, you have a gaseous fluid that is converted to liquid fluid. Here, a liquid fluid that is converted to gaseous fluid. So here in the heat exchange, latent heat of condensation and latent heat of evaporation is involved. Heat of condensation and latent heat of evaporation is involved. அப்படின்னா என்னன்னா இங்க ஒரு கேஸ் வந்து அதோட சேச்சுரேஷன் டெம்பரேச்சர் ஒரு ஃபார் எக்ஸாம்பிள் இஃப் யூ டேக் ஸ்டீம் அதோட சேச்சுரேஷன் டெம்பரேச்சர் அண்ட் சேச்சுரேஷன் ப்ரெஷர்ல வந்து அது வந்து லிக்விடா மாறணும் அப்படின்னா அது அந்த ரிலீஸ் பண்ற எனர்ஜி தான் லேட்டன்ட் ஹீட் ஆஃப் கண்டென்சேஷன். அதே மாதிரி ஒரு லிக்விட் பாயில் ஆயிட்டு இருக்கு, அது பாயில் ஆகிற லிக்விட் வந்து அதை வந்து ஸ்டீமா ஃபார் எக்ஸாம்பிள் வாட்டரை வந்து ஸ்டீமா நீங்க கன்வெர்ட் பண்ணணும். அது பாயில் ஆயிட்டு இருக்கு, இப்ப ஸ்டீமா கன்வெர்ட் பண்ணணும். ஸ்டீமா கன்வெர்ட் பண்ணும்போது அது நீங்க கொடுக்குற சப்ளை பண்ற எனர்ஜி தான் லேட்டன்ட் ஹீட் ஆஃப் evaporation. So you know that during latent heat of condensation and evaporation, the temperature remains constant. Temperature மாறாது. Temperature remains constant during the phase change process. Phase change process at that particular saturation pressure, the saturation temperature is constant, and it is vice versa. At the particular temperature, the saturation, for example, if I take water, the water, if you take water and when water is boiled, when water is boiled, it boils at 100 degrees Celsius. Why? Because the pressure exerted on water surface is 1 atmospheric pressure. So pressure plays an important role on boiling point. So if I boil water in an open pan, so what is subjected on the surface of water? Air is subjected. Air தான் வந்து வாட்டர் மேல ஆக்ட் ஆகுது. அப்போ நான் என்ன பண்றோம், நம்ம கீழே வந்து நம்ம ஹீட் பண்றோம். we are heating the water. நம்ம ஹீட் பண்ணும்போது என்ன பண்றோம், we are giving the heat energy to the water. So as I'm giving the heat energy to the water, suppose let the initial temperature of water is 30 degrees Celsius. Initial temperature heat பண்ணும்போது and you place a thermometer, the temperature will increase from 30 degrees, it increases to 40, 50, 60 etc. and it reaches to 100. 100 அப்புறம் நீங்க அப்சர்வ் பண்ணீங்கன்னா the temperature will remain constant. அப்படின்னா என்ன அர்த்தம், 100 டிகிரி ரீச் ஆனதுக்கு அப்புறம் இப்போ வாட்டர் இஸ் ரெடி டு கன்வெர்ட் டு ஸ்டீம். அந்த 100 டிகிரில பாயில் ஆயிட்டு இருக்கும், அந்த வாட்டர் என்ன ஆகும், அப்படியே கம்ப்ளீட்டா வந்து ஸ்டீமா சேஞ்ச் ஆயிடும். ஸோ இது ஏன் வந்து 100 டிகிரிஸ்ல ஏன் நடக்குது, what is the reason why it happens at 100 degree அப்படின்னு கேட்டீங்கன்னா, because the air that exerts a pressure on the water surface is 1 bar, and அப்போ இது 100 degrees அப்படின்றது வந்து it's not a constant value. Boiling point of water is 100 degrees Celsius is not a constant value. This boiling point can be changed. எப்படி சேஞ்ச் பண்ணோம், இந்த மேல எக்ஸர்ட் ஆகிற ப்ரெஷரை இன்க்ரீஸ் பண்ணீங்கன்னா வாட்டர் will not boil at 100. It may boil even at 150, 170 or 200 degrees Celsius. Similarly, so water will not, similarly, the pressure மேல act ஆகிற ப்ரெஷரை நீங்க குறைச்சிங்க அப்படின்னா, if you decrease this pressure, again, if you decrease this pressure exerted here, water will boil at a lesser temperature too. It's not necessary that it should boil at 100 degrees. It can boil at 60 degrees or 70 degrees or 80 degrees. So Himalayans, if you boil water in the Himalayan ranges, it will not boil at 100 degrees Celsius. It will boil at very less temperature because the pressure exerted on water surface is low. Because the higher the altitude you go up, the pressure decreases. So நீங்க ஹிமாலயன் மவுண்டன்ல போய் நீங்க வாட்டர் பண்ணா 100 டிகிரில வந்து கொதிக்காது. ஸோ ஃபேஸ் சேஞ்ச் ப்ராசஸ் அப்படின்றது நீங்க புரிஞ்சுக்கணும். என்னன்னா ஃபேஸ் சேஞ்ச் ப்ராசஸ்ல வந்துட்டு வாட்டர் இஸ் கன்வெர்டட் ஃபார் எக்ஸாம்பிள் இன்டு ஸ்டீம். நான் வாட்டர் எடுத்துனா இன்டு ஸ்டீம். அப்ப கன்வெர்ட் ஆகும்போது அந்த கன்வர்ஷன் கரெக்டா அந்த பாயிலிங் பாயிண்ட் ரீச் ஆனதுக்கு அப்புறம் என்ன ஆகும்? டெம்பரேச்சர் இஸ் constant. Temperature remains constant. This is the point you have to understand. Temperature மாறாது. எப்போ அது பாயில் ஆயிட்டு இருக்கும்போது இனிஷியலா ஹீட் பண்ணும்போது 30 டிகிரிஸ்ல இருக்கும்போது என்ன ஆகும்? டெம்பரேச்சர் இன்க்ரீஸ் ஆகும். எவ்வளவு இன்க்ரீஸ் ஆகுது? 40. அதுக்கப்புறம் 50, 60, 100. ஏன் 100 நின்னுக்குது? பிகாஸ் பிரஷர் இஸ் 1. கரெக்டா 100 வந்ததுக்கு அப்புறம் பாயில் ஆயிட்டே இருக்கும். நீங்க அப்சர்வ் பண்ணீங்கன்னா இது கம்ப்ளீட்லி தட் இஸ் கால்ட் நியூக்ளியர் பாயிலிங் சொல்லுவாங்க. We learn that again. இந்த கரெக்டா 100 degree Celsiusல the water will completely convert into steam here. So when it is completely converted into steam, the temperature remains constant. அப்ப டெம்பரேச்சர்லாம் கான்ஸ்டன்ட்னா நான் கொடுக்குற ஹீட் எனர்ஜி எங்க போகுது? Where does it go? That is called hidden heat or latent heat. எங்க போகுதுன்னா the given energy whatever you give, it is utilized to break the electrostatic force of attraction between the atoms and molecules. அதாவது ரெண்டு ஆட்டம்குள்ள இருக்கக்கூடிய அந்த ஃபோர்ஸை உடைக்கிறதுக்காக அந்த லேட்டன்ட் ஹீட்டை நம்ம யூஸ் பண்றோம். ஹீட் எனர்ஜி யூஸ் ஆயிக்குது. அதனால அது பேர் லேட்டன்ட் ஹீட் ஆர் ஹிடன் ஹீட். ஏன்னா நார்மலா ஒரு ஆப்ஜெக்டை நம்ம வந்து ஒரு சாலிடோ லிக்விடோ எதை நம்ம ஹீட் பண்ணோம், டெம்பரேச்சர் ரைஸ் ஆகும். இங்க ஆகலன்னா அந்த எனர்ஜி எங்க போகுது? அதோட மாலிகுல்ஸ் செப்பரேட் பண்றதுக்கு யூஸ் ஆகுது. ஸோ யூ ஆர் செப்பரேட்டிங் the energy. This is the force of attraction. The force of attraction is there between two atoms and molecules. Other separate பண்றதுக்கு you are giving the energy. That is called as latent heat. இத வந்து செப்பரேட் பண்றதுக்கு நீங்க கொடுக்கணும்னா latent heat of evaporation. இது ரெண்டு மாலிகுல் again நீங்க ஒன்னா இத க்ளோஸா கொண்டு வரணும் அப்படின்னா from a gas to liquid state close up கொண்டு வரணும்னா you have to remove the energy, or you have to see that it releases the energy. That is latent heat of condensation. அத வந்து செப்பரேட் பண்ணணும்னா latent heat of evaporation. So this is the basics of already you have studied in thermodynamics and you have this knowledge. So this condenser and evaporator is also heat exchanger. Only thing you have to understand is there are two fluids always in a heat exchanger. As far as condenser and evaporator, one fluid temperature will always remain constant. So this is the point ultimately you have to understand. So let us draw the temperature and length diagram. So you will understand for condenser. So let me draw it for a condenser. So this is the condenser. Temperature distribution in a condenser. Temperature distribution in a condenser. Temperature distribution in a condenser. Okay, the temperature distribution in a condenser. Similarly, you can see it in an temperature distribution in an evaporator. Okay, let me see it here. Adjust it. Okay, now we'll see here. These are the length. This is the length, and this is the say temperature. Okay, this is a condenser. So this is the first one is a condenser. அப்ப கண்டென்சர்ல நம்ம என்ன பண்ண போறோம்? What we are going to do in a condenser? Okay. For example, let me say steam. Steam is going to condense into, say, for example, steam is going to condense into water, liquid. Okay, water. It's going to convert into water, liquid or water. சரிங்களா? பண்ணும்போது கரெக்டா அந்த சேச்சுரேஷன் டெம்பரேச்சர்ல எக்ஸாக்ட்லி the saturation temperature or pressure என்ன ஆகும்? Temperature will remain constant. இப்போ நான் என்ன பண்றேன்? இப்போ you have, say for example, imagine this is your heat exchanger. Okay, here in the tube இருக்கு. இந்த டியூபுக்குள்ள for example you have cold fluid. இதுல வந்து you have cold fluid. ஏன் cold fluid? ஹீட் எக்ஸ்சேஞ்ச் நடக்கணும், என்ன நடக்கணும்? ஒரு ஹாட் ஃப்ளூயிட் வேணும், கோல்ட் ஃப்ளூயிட் வேணும். ஸோ கோல்ட் ஃப்ளூயிட் போகுது. சரிங்களா? உங்க ஸ்டீம் எங்க வருது? ஆக்ட் ஆகுது சர்ஃபேஸ் டியூபுக்கு மேல. ஸோ திஸ் இஸ் steam that acts on the tube surfaces. Say for example, steam act ஆகுது. This is the steam hot fluid. Correct? Hot fluid. Right. Now there's a surface which separates this hot fluid and cold fluid. So the surface மீறி என்ன பண்ணும் heat exchange. Hot fluid will exchange the heat energy to cold fluid. ஏன்னா இது higher temperature இது lower temperature. There is heat transfer. There is heat transfer. அப்ப என்ன ஆகும் ஸ்டீம் இருக்கு இல்லைங்களா ஸ்டீம் வந்து சப்போஸ் இட் இஸ் அட் 100 டிகிரி செல்சியஸ் ஸ்டீம் வந்துச்சுன்னா 100 டிகிரி செல்சியஸ் ஸ்டீம்ல வந்துச்சுன்னா and for example you take a simple example, say you are having a water say 60 degrees Celsius or say 40, for example 40 degrees Celsius. In the cold water may come at say for example 90 degrees Celsius for example. இங்க temperature increase ஆகும் sensible heat water temperature increase ஆகும். ஆனா இந்த இடத்துல இந்த ஸ்டீம் இருக்கு இல்லைங்களா 100 degree Celsius at 1 bar pressureல வரும்போது என்ன ஆகும் இது இந்த heat exchange பண்ண it will remain as 100 degrees Celsius. It will remain as 100 degrees Celsius. 100 degrees Celsius water condensate. 100 degrees Celsius. இது cold fluid. இது hot ஆயிட்டு போகுது. இப்ப heat exchange ஆயிட்டே இருக்கு. ஆகும்போது என்ன ஆகுது கொஞ்சம் கொஞ்சமா you have droplets of water here. Droplets of water. என்ன temperature இருக்குன்னு நினைக்கிறீங்க same 100 degrees Celsius because the pressure is 1 bar. சரிங்களா so you understand what I'm saying. So the steam okay that falls on this surface of this pipe through which a cold fluid is going, the steam will condense, the temperature remains constant, it will not change because the pressure is 1 bar. At 1 bar it will be at 100 degree. But if you see if you take the applications as far as the power plant is concerned, the temperature will not be 100, it will be more than 100 degrees Celsius. You don't operate. For example, you take a boiler in a power plant. The boiler will be operated at say for example 20 bar pressure, 275 or 300 degree Celsius. Steam will be operated. So you don't operate at temperatures of 101 bar. You go for higher temperature, higher pressure. You need more energy for power generation. So that is the point. So here now you need two fluids. One fluid is this steam. This steam. One fluid is steam. What is another fluid? The cold liquid here. Sorry, the one is steam here. The another one is the cold fluid here. One is hot fluid. One is cold fluid. If hot fluid temperature na irukku. Hot fluid temperature constant. So hot fluid temperature மாறல. So I'm drawing a straight line. Right. This is temperature. Hot fluid or temperature. Temperature of hot fluid. So TH1 inletல வெளியில வரும்போது என்னது TH2 same. For example 100 degrees னா எவ்வளவு இருக்கும் 100 degrees na it will come out as 100. இங்க என்ன கண்டிஷன்ல இருக்கும் இங்க என்ன கண்டிஷன்ல இருக்கு இங்க இந்த கண்டிஷன் what is the condition here? The condition here is 100 degrees Celsius steam. As the heat transfers along the pipe, it will become 100 degrees Celsius condensed water gradually. Another cold fluid and now it enters at 40 and leaves at 90. Other temperature increase now. So let me draw the cold water here. The cold water which enters at say for example 40 degrees Celsius, say 40 degree, will reach at say for example say somewhere 90 degrees Celsius. Example it reaches at 90 degrees Celsius. You can see here. Okay. So here the cold water 40 degrees Celsius 90. So the cold water TC1 and TC2 are not same. You understand? So this is the temperature distribution in the condenser. So throughout the length of see from 40 degree it enters here, it leaves at 90. 40 degree it enters, it gradually the temperature increases. It exchanges heat from the hot fluid. That's a heat exchange from the hot fluid here. Hot fluid. You can see it. That's a heat exchange from the hot fluid. But temperature of hot fluid remains constant. That is what you have to understand. Right? So similarly, we'll draw a diagram for a evaporator. Let me draw a diagram for evaporator. And it's going to be the similar one. Okay. Let me draw a shorter one here. Okay. Now here, what is the condition here? Now what is the condition here? Here in an evaporator, you have, for example, evaporator or boiler, you have let me say water. Water is there, enters here, and it is converted into steam. Or in general, this is in the case of a boiler. In the case of a boiler, liquid water entering into a boiler, it converts into steam. It is also an evaporator. Or in the case of a refrigerator, you have a liquid refrigerant that enters the evaporator, and by coming out, it becomes a gaseous refrigerant. Gaseous refrigerant. So there you call it as a refrigerant. Non-CFC refrigerants. Okay, here gaseous refrigerant. So either it may be a boiler or evaporator. So you can say the liquid fluid converts into gaseous fluid. So while the conversion water is constant, again temperature remains constant. So now what I do here? So now you can see here the in an evaporator you can see that you have hot fluid is here and there is a cold fluid. So which is the hot fluid here? Which is the hot fluid? Which is the hot fluid? The fluid water is going to convert into steam. Temperature is going to be constant. Okay, you can see here. So temperature is going to remain constant. TC1. This is the cold fluid. TC1, TC2. This is the cold fluid because it's water. The energy is less. After converting to steam, okay, energy is more. The latent heat it has absorbed. Now the hot fluid, whatever hot fluid that exchanges heat here, the hot fluid, gradually what it happens, the hot fluid as it comes in contact with the liquid, the hot fluid gradually the temperature decreases. So this is temperature of hot 1, temperature of hot fluid 2 at exit. I hope you understand. So here the steam to be condensed, it exchanges the heat energy with the cold fluid. Here the liquid which has to evaporate, it exchanges heat from the hot fluid. So from here heat is exchanged at throughout the length of the flow when it is flowing through the pipe, and every instant heat is exchanged. So with this, the classification of the heat exchangers, a detailed classification has been given. So go through this classification, and this will help you to as far as examination of point of view is concerned. This will help you to secure marks, 2 marks. Maybe the questions are what are the different types of heat exchanger? What is a compact heat exchanger? Define a compact heat exchanger. Classification of heat exchangers. Okay, all these kind of questions you can expect. With this, I will conclude this video, and we'll go for the next video, which will involve heat exchanger analysis. So the next video we will discuss about heat exchanger analysis. Thank you.